All right, welcome to a video on section 10.3 from Math 1. This is conditional statements. So this is the handout that I gave you earlier today. We have conditional statements is the title of this section. That's what it kind of says. It's a little blocked. It's the same thing that's what shown here. This goes on page 11. So I showed you guys how to fold it. This was how it looks. And you fold it along this side and this side, and then you do have to do a little cutting. You can see where I've highlighted in yellow. That's where you're going to cut just to the fold. So there should be 4 cuts. So when the paper is all flat, it looks like this. So these yellow things represent where you cut just to the fold. Okay, so these are the titles. You can go ahead and write these on there. Feel free to pause the video if you need to take more time to write them down. So we have conditional statements, converse, negation, inverse, contrapositive, and equivalent statements. So let's go ahead and get started with conditional statements. I'm going to zoom in a little bit. All right, so what are conditional statements? So conditional statements are things that you use all the time. Basically, it's any statement that is of the form, it's an if-then statement. So if, then statement. Didn't really space that out very well. Okay, so for example, we have an example here that says, if today is Halloween, then it is October, right? Or there's lots of statements that we make on a day-to-day basis, like if today is Tuesday, then I have basketball practice, or if today is Friday, then I'm gonna go out with my friends, or you know, you can think of a million of them, right? Okay, so conditional statements can be true or false. So they don't necessarily have to be true. This one right here, if today is Halloween, then it is October, is a totally true statement. As we go through this, we're going to run into some that are false. Okay. Now there's 2 parts to a conditional statement. There's the hypothesis, and the hypothesis is the part that's after the if. Okay. So it's the part after the if, but before the then. Okay, and then we have the conclusion. The conclusion is the part that's after the then. So in our case, it would be it is October. All right, so part after then. Okay, we also have something called symbolic notation. Instead of writing it all in words, sometimes we replace parts with variables. For example, we could make the hypothesis be P. So we usually use the letter P and the letter Q, but it doesn't matter what letter. And we can also use the conclusion, let's call that Q. So P represents today is Halloween. Q represents it is October. So an if-then statement has sort of a direction. If today is October, then we can make the connection that it is October. And so the way that the symbolic notation works is we use an arrow. So P has to happen in order for Q to happen. Okay? For example, in our example about if it's Tuesday, you have basketball practice. Okay? If Tuesday happens, so it's Tuesday, then basketball practice happens, right? One leads to the other. All right, so that's conditional statements. So underneath conditional statements, we have converse. So let's go ahead to the one right here. Let's look at the converse. Okay, so a converse of a conditional statement is the result of switching the hypothesis and the conclusion. So let's take our example of if today is Halloween, then it is October. So what we're going to do is we're going to take the hypothesis, which is today is Halloween, and the conclusion, which is it is October, and we're going to swap that. Now, the if and the then are going to stay exactly where they were. So it's still going to start with if, and so it's going to change a little bit. It's going to be if today is or it is October, then it is or we could say today is Halloween. So you see we switched it is October and today is Halloween. So the hypothesis and the conclusion switch. Okay, now symbolic notation wise, we can say Q is first, then P. The way that you read it in symbolic notation with the arrow is you use the word implies. Okay, so this would be Q implies P. Now let's think about this for a second. Is this true? This sentence? If it is October, then today is Halloween. That is not true. That is false, right? And we can come up with a pretty easy counterexample, such as October 2nd. That is a day in October. So that satisfies the hypothesis. That makes that true. But it doesn't lead to the fact that it's Halloween, does it? October 2nd is not Halloween. So this converse is a false statement. Okay. Next, we're going to look at negation. So the negation of a statement is the opposite of the statement. Okay, and we have the verb to negate, and negation is more of a noun. Okay, but we kind of use both of them in this sense. So basically you're going to take the opposite meaning. So let's look at our examples. Examples: negate each statement. The first one says the cat is black. Well, if you're thinking like changing the color from black to the opposite of black, it's not like that. We're just going to say that the cat is not black. So really we're just going to write it and we're going to put the word not in there. This is the exact opposite of saying the cat is black. We add the word not. Okay? We could do that more mathematically for the second one. It says x equals 4. Well, one way that we say the opposite of equals is we put a line through it. That means x does not equal 4. And so the not part comes with this line. All right? What if it already has a not? Like this sentence says, it is not Saturday. Well, if it already has a not, then we're going to just remove it because we don't want two nots, right? No double negatives. So it is Saturday would be the opposite of this one. So we remove the not in this case. So negation comes in our next one, inverse. So on the top right, let's take a look at inverse. Okay, so the inverse of a conditional statement is the result of negating both the hypothesis and the conclusion. Okay, so they're not going to move, but we're going to introduce the word not. So for example, if today is Halloween, then it is October, would be rewritten for the inverse as if today is not Halloween, then it is not October. Okay, so you see for both the hypothesis and the conclusion, we negated it. And I forgot to mention, there's a symbol for that. I didn't have it on the handout, but I wrote it in on your copy. The symbolic notation for negation is a symbol that looks like, oops, sorry. It's a symbol that looks something like this. There's actually more than one symbol. I believe this is also a symbol for not, but I think this one is the one that your book recognizes. Okay, so the symbolic notation for an inverse, we're going to do not P implies not Q. So we use two of them. Okay, let's think about this. Let's decide if this is true or false. If today is not Halloween, then it is not October. Well, can you think of a day that's not Halloween, but actually is October? I can. I can think of about 30 days, right? So this is false. And again, we can use the same exact counterexample, October 2nd. Okay, October 2nd is not Halloween, right? So it makes the first part, it works for the first part. And so if it works, then that means, according to the statement at least, that it's not October. But we know that October 2nd is October, so that doesn't make any sense. So we have to say that the statement is false. Okay. All right, next we have the contrapositive. So we're right on this one. A contrapositive of a conditional statement is the result of negating, so just like before, and switching the hypothesis and the conclusion. So you can kind of think of it as an inverse, which is the negating, and a converse at the same time. Okay? So you kind of have to keep track of it and do two things. All right, so back to our Halloween example. If, and then I'm going to switch them. So I'm going to start by taking it is October and I'm going to put it first. But the big difference here is I'm going to negate it. So I'm going to write if it is not October, then, now I'm going to put the first part, which was today is Halloween, but remember we're going to negate it. So then today is not Halloween. Okay, so let's think about that. Is that true? If today is not October, so it's not a day in October, then it's not Halloween. That's true. It can't not be October and be Halloween, right? So it doesn't work. I mean, well, it does work. It does work. It's a true statement. Okay, so the symbolic notation is we're going to do not Q, because remember we negated it, implies not P. So I'm going to zoom out for a second. So we had these four statements. We had the converse, the inverse, the original, and the counterexample. Okay, so the original statement that we had, if today is Halloween, then it is October. This is true. The converse was false. The inverse was false. And the contrapositive was true. And so you'll notice that the original and the contrapositive are true. And the inverse and the converse were both false. And there's something going on here. We have what's known as equivalent statements. So that's our last one here. Okay. Basically think of it. Okay, oh yeah, there's a typo here. Okay, we need to fix something. Scribble out converse here. A conditional statement and its contrapositive is what it's supposed to say, are called logically equivalent statements because they have the same truth value. Okay, and you can see the contrapositive, which was this one, is true, and the original was true. Okay, another pair that also has a that are logically equivalent are the converse and the inverse. Okay, and so there's another full example over here that shows that this works. This is a geometry example. It's talking about acute angles. In case you don't know what an acute angle is, it's an angle that's between 0 and 90 degrees, but it can't equal 90 degrees. So we have our conditional statement. If an angle measures 40 degrees, then it is an acute angle. So let's think about that. Is that true? Yeah. If you have a 40-degree angle, here's an angle, 40 degrees, it's acute because it's between 0 and 90 degrees. Okay, let's look at the next one. If an angle is an acute angle, then it measures 40 degrees. That's the converse. So we switch the hypothesis and the conclusion. Is that true? That's not true. That's false. Just because it's acute doesn't mean it has to be 40 degrees. It might be 41 degrees. That's still between 0 and 90. Okay, let's look at the inverse. If an angle does not measure 40 degrees, then it is not an acute angle. That's kind of going the same way as the converse. That's kind of saying if it's acute, it has to be 40, or if it's 40, it has to be acute. No, that's not true. It could be anything between 0 and 90. So that's false. All right, and then the contrapositive says, this is where we switch it and negate it. If an angle is not acute, then it does not measure 40 degrees. Well, if an angle is not acute, then that means it's not between 0 and 90 degrees. So how could it possibly measure 40, right? So this is actually true. If it's not acute, it can't be 40. Okay? So you could see that the true ones are the conditional and the contrapositive. These are pretty much saying the same thing. They're equivalent. And then the false ones are the converse and the inverse. Okay, now it doesn't always have to be some are true and some are false. Sometimes they're all true and sometimes they're all false. So it kind of depends on the statement, but you're always going to have this pairing up of the same truth value. Okay? All right, that's it, and feel free to rewatch this if you need to go over any of the parts again, okay?